Hey, what's up, people? It is assembly time today. Gonna be putting in, as the video title should specify, a retro chip tester pro. And I've had this thing kicking around for just under 3 years now. And I've been needing to put it together, and today is the day. So, if you're not too familiar with the retro chip tester pro, you basically buy this board from Stefan Slabyhood. I don't know if that's how you pronounce his last name, but he's the one that designed this board. And I'm not going to go into like crazy details about it because all the information is on his website. But you can order this directly from him. You get the board already populated with the microcontroller, as well as one of the voltage regulators and the USB port, which I don't think, no, it's not on here yet. It's somewhere in one of the little bags. So you have to basically acquire everything else yourself. So I had already done so, and I've got everything that I should need already in these bags. So it's really just a matter of putting everything together. I've got extra parts here because some of the stuff that I bought, came in like lots or whatever of like multiple like sockets, for example. Like I think I really only need like one of these, but I ended up with, a couple extras. So not a big deal. So I'm going to sort everything out by height, basically. Like I want to start putting in like all the smaller, lower profile stuff first, and then work my way up from there. But the first thing I actually do want to do is update the firmware on the microcontroller, which happens to be an ATmega 2560. And the cool thing is that Stefan, he emails you whenever there's a firmware update, so you can download the newest one. And so I actually did see an email just from a few days ago, and I did download the newest firmware. So it's going to be a matter of, I'm going to have to look it up again because I don't remember exactly how or where the pins for programming the microcontroller are, but it should be fairly straightforward. And here I've got everything laid out. Now, as I mentioned, the core kit that you buy from Stefan is this board, and I misspoke when I said the voltage regulator. It's a voltage regulator board, which is a smaller board that actually mounts to the main board up in this area. There is a little USB port just for providing power. And then there's this other adapter that I don't remember it being mentioned, but I guess it was part of the kit because I have it and I don't remember paying for anything extra. So everything else you do have to supply yourself, but you do get a bill of materials where you can go through and maybe, like dig up what parts you might have on hand, which is what I have in this stack of bags. So these are things that I already had in like my little stock of stuff. But, you can get everything else you need from other places online or, local stores if you have them. And as you can see, I got a lot of stuff that I had to order from DigiKey, as well as things that I got from other places, such as MPJA, or it's Marlon P. Jones and Associates. This is a place in Florida that you can mail order from. And they have like a bunch of usually kind of like oddball stuff. And so this is a 4x20 character LCD. So that's something that I'm going to need for this. And then a few other things. This is a USBASP programmer, and this is what I'm going to use to update the firmware on the microcontroller. And this was acquired from eBay, so I actually had gotten like a pack of 2, but I mean, I just need the one. So this is a component lead bender, and this is actually something I printed out. So I just found the model on Thingiverse. I could have like made it my own, but somebody had already done so. So I just printed this out. Inside, I actually have some adapters that I made because of some of the components that I ordered. I'm going to talk a little more in detail of those things like in a little bit, but this is going to make it so that I can have like really nice, neat bends for like the resistors and some of the diodes. And then I got 2 of these. I'm not sure which one I'm going to use just yet, but these are just little basic micro SD card adapters. And there is a spot on the board where we can put a little header in to plug one of these in. I don't know if I'm going to be able to use this one that I put. Actually, I think it came with a right angle plug like that, and I put a straight plug on this one. So I'm not sure which one's going to work better, or maybe I can, like reposition it or something, but got a couple of those. Those were also eBay components. These are a bunch of plastic standoffs and screws. And I'm basically going to be using these for like the corners just to kind of raise the board off of the surface of the bench or wherever, I decide to place it. I'm guessing they're probably like nylon or something, just to prevent, like stuff from like shorting out. And I can also use these to kind of like bolt down the voltage regulators to the board so that they're not like flopping around or vibrating. Now, one kind of funny thing I didn't notice here is that it actually says metal rivet on this label, but they're all plastic. Now, I mentioned that I wanted to update the firmware on the microcontroller, but there's a few capacitors that are supposed to be populated on the board that are like, the power rails for the microcontroller. So I think I'm going to wait until it's fully built before I do that, just to avoid like any headaches with like, noisy signals or whatever. So I'm just going to kind of move everything off to the side. I'm going to start with resistors and diodes and devices that are, just going to be like laying flat. Like, for example, all the ones that are going to go in this area, as well as like a few up here, and then some other ones like scattered throughout the boards. But something I do want to do before I actually start soldering things in place is I want to put some of these standoffs on it. And then that way the board can be kind of like, lifted up off the surface so that when I flip it over, I can just like kind of like set it down, solder in whatever components I've put in there. So I'm just going to choose maybe like these 1/4 inch looking ones along with the taller ones. These are going to be for the top side, and I'm just going to apply these to the corners, just like so. So then that way it can rest on that. And I've got all 4 of them on, and I can, reconfigure this stuff after I'm done building it. For now, I just want to be able to set it down like on that side without things being all like wonky. Now, regarding the resistors, there's a bunch that go in this area. And when I ordered them, I ordered 1/4 watt resistors at the right values that are supposed to be there. What I didn't realize when I ordered these from DigiKey is that they are 1/4 watt resistors, but they are basically like the 1/8 inch, or not 1/8, 1/8 watt size. So to try to get these to bend at the wider pin spacing, I didn't want them to look all, kind of like lopsided or anything. So when I printed out this component lead bender, I also printed out these inserts that I can place on the inside, and then that way I can have the resistors laying in the center, and then I can bend the leads out and have them all hopefully be, pretty evenly spaced so that they don't look weird. And then as you can see, that should allow me to get them to bend so that they are evenly spaced. Well, it's kind of hard to see there. Actually, I think I need to use this side. Yeah, so it's going to be like this end. So that should make them so that they're nice and neat and not all weird. So let's see how it goes. And yeah, this is actually working out pretty well. You can see that all the resistors mostly look aligned. There's a few that look slightly off, but not very much. And as far as the pin goes, they're fairly even. At least they're all pretty consistent. And the cool thing is that as I bend the leads, I can place 2 resistors at a time on the end of the bender, and then just give them a bend like that. And then I have 2 resistors ready to go, and it's as easy as that. And at this point, I've got all the 470 ohm resistors fully populated. I don't think I missed any. I've kind of double checked and I don't see any empty spots. So I think that should be it for those. Now, I'm going to do something a little different than I would normally do when soldering components like this to a board. And that is that I am actually going to solder them from the top. And the holes on this, all the holes on this board are plated through. So the solder should be able to flow from the top to the bottom. But the reason I'm kind of doing that is because it was a lot faster for me to just stick all the resistors in after bending them and, not go through the bottom and like bend everything so that it holds in place. I actually ended up putting a few more of these like standoffs on the main standoff that I put there so that the pins would all clear. And as you can see down at the bottom, I have not like bent any of those to hold the resistors in place. So after I get these soldered from the top, and they are nice and secure, I can actually go through the bottom and try to trim all of the resistor leads so that they are fairly not completely flush with the bottom of the board. I will leave like a tiny little bit like exposed, but then what I can do after that is apply a bit of flux to the bottom and then go through and like touch them all with the soldering iron again and get that solder to flow and hopefully make a nice joint at every single one of those pins. I just need to heat this thing up and then we can see how that turns out. And that went pretty uneventful. It was just as I'd hoped. So up on the top side where I was using the rosin core solder, you can kind of see a little bit of a spattering there, but that's just like the flux itself. So I'll give all that a cleaning once I'm like done attaching the rest of the components. And on the bottom side, it all looks pretty good as well, but you can see that there's a lot of flux residue that will need to be cleaned, but I will worry about that once I've put some of the other components on. So I'm basically just going to do the same technique for the rest of the resistors and like the diodes and anything else that's kind of flat like that, although I think that's about it for those. I've got the rest of the resistors and the diodes installed, as well as all the diodes on the socket side. And a couple things I thought I would point out. All the diodes that are installed on the board are DO41 package diodes, and they have fairly thick leads in comparison to like the resistors. And if I actually stick one into one of the holes on the board, you can see how that lead like almost pretty much completely fills up the hole. So getting these components to fit into their proper places was actually a little bit of a chore, because even though I would bend the leads to try to get them in because they are so close to the body of the diode, it was kind of a tight fit trying to get the diode to sit flush on the board. I managed to get it all done, but the fact that there's not much room for those pins made it, I think, a little bit more of a struggle than it could have been. It's not the same case on the little power supply board. The spacing on the pins for this diode, it's basically the only diode that goes up on this board, it's a little bit wider, and also the holes are a little bit bigger, so it's really easy to get the diode onto that board like that. See, it like fits in there just fine, but you can see how in comparison to one of the other ones, the leads are not as tight to the body as the ones on the main board. And another thing is that when I ordered the transistors, I don't know why I did this, but I ordered these that come in the strips and have the leads kind of like spread out and then back out. On the board, as you can see, the majority of these, it's the ones where the leads are, like directly on the bottom of the transistor package itself. So it would have made more sense to get transistors like this, where all the leads are just coming like right out of the package and just, keep going straight out, because then all you have to do is just take the one pin in the middle, bend it back just a little bit, and then that can be inserted like wherever a transistor is needed, like right there, for example. And then you can just, push it down until the leads spread out enough and the transistor is not like totally like raised off the board where it'll be easy to like break off. So what I'm having to do is to like cut off a transistor from the strip and then take these cool little purple duckbill pliers and go through. And if this would focus, there we go. Just kind of like unbend them and make sure that all of the pins coming out of the package are parallel once again. Just like that and like that. And then I just take the middle one and give it a slight push back. Make sure all these, there we go. I did mention that I got this stuff like almost 3 years ago. It's been about 2.5 years since I bought all this stuff, so I don't really remember any details, but it could have been that maybe these were the only ones that I was able to get, like when parts were like pretty slim pickings. So that would make more sense as to why I got these, because otherwise I can't really think of why I would have done it unless I just wasn't paying attention, which is another possibility. I probably just wasn't paying attention to the pin spacing, but I mean, either way, we can make them work, so it's not a big deal. Oh, and another thing, because I'm going to be using sockets to interface the LCD and the little power supply board to the main board, I have to have one of the sockets like on the main board, and then I have to have the matching pins on the upper board. And unfortunately, the standoffs that I have, there's two sizes that I can use for this. There's these slightly longer ones, slightly longer ones, and these slightly shorter ones. Well, when we have pins on any one of these headers, like say for example here, I don't want to like put the whole thing in, but just like that, the shorter standoffs are a little too short, and then the board is not able to sit like flush with the standoff while having the pins like mate to the connector. And if I use the slightly longer one, then the pins are slightly separated from the connector and they're not sitting like in there completely flush. So I wanted to make sure that everything fits flush. And what I ended up doing is printing out these nuts. Well, they're not really nuts, but they're kind of like spacers that are going to go in between the standoff and the board. You can see I put one right there. It's really not noticeable. I wanted to make them so that they're not very noticeable, but I also got one down on that one and down on this one, so that when I actually put the board, or like the LCD in this case, to the board, it sits completely flush, and I'm able to attach it to these standoffs, and I don't have like gaps anywhere on the connector or on the standoffs themselves. So I like that much better. And what I did was I sort of like measured the difference between the shortest, one of these shorter standoffs and the board, and that came out to be about like 0.7 millimeters. So yeah, as you can see, they're not very thick, but it's just enough to make it so that I don't have like any issues. For some reason, I seem to love living life on hard mode and making things more difficult for myself than they should be. And some of you may have thought about this already, but what I could have done is measure a fully meshed set of pins and headers and see what the correct length of the standoff should be, and compare that to the length of one of the shorter standoffs. And it turns out that the pins measure at 11 millimeters, while the standoff measures at 10 millimeters. So I would need like a 1 millimeter spacer, but the 0.7 millimeter one that I designed was close enough that it does help. So I can just leave these in for the time being. And at this point, I have the majority of the components soldered in, and in my opinion, it's looking pretty good. The other components that I've currently left off the board are some potentiometers, the little piezo buzzer, there's some buttons in this portion, and the electrolytic capacitor that needs to go in that spot. And I left those out at the moment just because I want to give this board an ultrasonic cleaning. I don't want like water getting inside and, making it really difficult to get them out. I'm not too worried if water gets inside of these headers, because then I can just use compressed air to blow them out, as well as like this socket. So those are not a big deal. One little issue with the capacitor that's going to go in that spot is that the only ones I have are these electrolytics that measure about 12 millimeters tall. Well, they would interfere with the LCD that's going to drop in place. And so what I'm going to do for that one is that I'm just going to like bend the leads at a right angle so that I can just solder it in sideways. So it's just going to sit flat on the board like so. And then that way it won't interfere with the board. Fortunately, I don't have any that are, shorter, maybe like a little bit stubbier, that'll fit in that spot and, still stay standing up. So that's what I'm doing for that. There are some optional components that are not populated, such as USB ports on this side of the board. And it's basically, so you have the option of like using a type B port, or like a smaller mini or a micro, as well as this polyfuse to protect the voltage line coming from these USB ports. And there's also, you can install some like screw down connectors on this portion, but I'm also not going to use those. There would be a 5-volt regulator installed in this spot, along with some capacitors and some jumpers. And the reason why I didn't populate this is because the other power supply board that's going to sit on top is the one that's going to be taking care of doing the 5-volt regulation and all that stuff. So if you're just going to use this board with 5-volt components, and you know that you're not going to be doing anything with any other like ICs or memory chips that require like those funky negative voltages, then you can just stick with that. But I don't know what exactly I'm going to be testing with this, and I want to have the option to test components that may need those other voltages. And so that's why I'm going with the voltage regulator board. There would be a tiny P MOSFET in that spot, but that's because you have the option of using the TO220 device or the MOSFET. I just went with the TO220, so that's why I populated that. This diode is not necessary. It's only if you're actually going to be using this 7805 regulator. While I was putting all the diodes in, I just stuck it in there and soldered it in, and then I realized, oh wait, I didn't have to do that one. So I'm just going to leave that one in place. I'm not going to worry about it. I took a little bit of liberty with choosing some of the LEDs that I soldered onto the boards, such as for power, I put in a green one. For VCC, I put in a red, because usually on like the power supplies, the red wires are the 5-volt. And for this active LED, I had this square orange LED kicking around in my container of LEDs, and when it lights up, it's like a dark orange and it almost looks red. So I kind of used it as like a like to symbolize like stop, I'm doing something. So at a glance, I can kind of tell like, oh, I shouldn't mess with the thing. The only thing that may be an issue is the resistor. I had actually calculated the resistor needed for this LED to be at about 220 ohms. And I completely forgot about it because, like I said, I've had everything sitting around for several years now. But I had written it down in the spot right there that for the active to use a 220 ohm resistor. But I'll leave the 470 ohm in there for now. See how it looks. If it's like way too dim, then maybe I'll swap it out. Hopefully it'll be bright enough to actually be noticeable though. And on the power supply board, or the regulator board, on the parts list, he suggested going with like red for the D, which is D2, which is this spot right there for power. But I actually went with a green one for that because I wanted to signify that this board is getting a power input. And then for the other ones, I put here green, but I went with a yellow, red, and white. Yellow because on a like standard PC power supply, that signifies 12 volts. The red signifies 5, and then white signifies -5. So this way, if for some reason something's not working properly, I can just at a glance see which voltage is missing instead of having all green LEDs and being like, okay, which one is, okay, so that's 12 or whatever. I can just be like, oh, it's missing 12 or it's missing -5. Again, I kind of calculated different value resistors for these, but I think what Stefan, the guy that designed this, was going for was maybe like 15 milliamps per LEDs, and with these values that are in place, it seems like they should be fine. They're kind of ranging between like about 12 to 15 milliamps. I just don't want any one of these to be like, brighter than the other one. So if I have to tweak the values a little bit, then I will. In R3, there was supposed to be a 750 ohm resistor, but I don't have any. So I went with an 820 ohm resistor. That was like the next closest value that I had. So hopefully that should be fine. Again, I did not put in the electrolytics yet. I want to give this board a good cleaning with the ultrasonic bath. I don't know how like ultrasonic cleaning affects electrolytics, and I don't want to like, maybe risk like the high frequency vibration somehow doing something to it. I think I'd have to do a little more research on that. So before I clean them, I didn't want to have the capacitors in place. One issue I am going to have with cleaning this board is that my ultrasonic cleaner is a little too small to be able to fit the entire board flat inside of it. So what I think I'm going to do first is I will actually kind of use some IPA to wipe off as much of the flux. As you can see on the board, I use quite a bit of flux to try to make sure that all those solder joints were like nice and neat and like fully filled in without having like massive globs or anything or cold solder joints. And then once I get this or the majority of the flux cleaned off, then I'll try to finish it off with the ultrasonic cleaner by maybe just going in like sideways, like, one side at a time. So that's the plan. We'll see how it goes. Oh, and on the somewhat completely unrelated note, for a while, I had actually been looking for a silicone solder mat to like do this type of work on. But all the ones that I kept seeing were like pretty small, and none of them really ever kind of got my attention. But then I found out that Gamers Nexus was selling this like a pretty large one. And I don't know if any other bigger ones exist, but this is the biggest one that I know about. And so I picked one up. And it's actually been pretty awesome. I like the fact that it's got a bunch of like little containers, and it's helped me like keep like stuff under control, like keep it from like rolling off the bench, because it has a bit of a lip in the front. Unfortunately, due to the way that I designed my bench, the front end kind of sags down a little bit, so stuff tends to like kind of like roll off in this direction and like fall down. I'd have to put like some sort of bracing underneath to maybe like lift this up a bit to prevent that from happening. But I'm actually mostly happy with this mat. The only thing I don't really like is, if you can see right there, there's a piece of one of the component leads that I clipped off. And because they have the logo kind of like embossed in there, if like a lead falls in there, it makes it kind of difficult to get out. I have to kind of like dig in there to get it out. And now I just went to the other side. So things like that sort of get caught in the logo, which is a bit unfortunate, but I mean, it's not that big of a deal. And this is not sponsored or anything. It's not like they sent this to me or anything like that. I bought this with my own money. I just thought I would, point it out if there's anybody out there kind of like looking for something similar. This one is working out pretty well for me, so I thought I would just share that information. Well, I cleaned up mostly okay. There's a few areas where the rosin core flux kind of left a little more than I would have wanted it to. But the only way I can get rid of those is if I go with a swab, kind of break them up and then kind of wipe them off. I mean, it won't really affect anything. I just wanted this to be a little bit cleaner than it actually came out. Like you can see some right there. Break it up and then try to wipe it off. So yeah, I think if I want to make this thing like look completely flawless, I'm just going to have to manually go through and get rid of some of this remainder of the flux. Getting down to the last few steps before we can try to power this up, and a couple of things I want to talk about before I put the LCD on is there is a volume potentiometer, pads available for it on this section of the board, and that's for the piezo buzzer so that you can adjust how loud it is. And the parts list calls for a 1K potentiometer, and I thought I had one, and I had already like set this apart, but when I was about to install it, I realized that I read it wrong. So a 1K potentiometer would be marked 102. However, I didn't realize until I was about to put it on that I actually read this upside down, and this one's actually 201. So this is a 200 ohm potentiometer, and unfortunately I didn't have any 1K potentiometers on hand. I did have a 501, which is a 500 ohm potentiometer, and the potentiometer itself is not absolutely necessary for like this application. You can actually just like jump across those two pins if you want, but then the sound coming out of the piezo is going to be, you know, as loud as it gets. And I would like to have some adjustability just due to the fact that if I'm going to be, you know, testing something on video or whatever, I don't want it to be like, you know, crazy loud or anything. So I'll try this 500 ohm potentiometer and see how it does. If it even just makes it so that it's not like too obnoxiously loud, then that's fine. And then the other thing I kind of wanted to mention is there is the 6-pin pads for the ICSP or the in-circuit serial programmer for the microcontroller. That's where the programmer would plug in so that we can update the firmware. Well, I could have just put like a regular little 6-pin header like, you know, I used in some of the other spots. But I wanted to use this one with the shroud because it's keyed. And that means that I can basically take one of these connectors and I can only insert it one way. Now, unfortunately, the adapter that comes with the USBASP programmer is this rectangular header that can pretty much go in like any direction. And I don't want to accidentally plug this in the wrong way, you know, if I'm like not paying attention or something, or I'm like, you know, just get distracted. So what I thought was, well, I'll take this cable and then I'll modify one of these connectors because the header on the actual programmer is a 10-pin header. And so this is, you know, definitely has no way of fitting on there. But not only that, even if I could make it fit, the pinout is not the same. So I would have to like remove the end of this connector and put in like one of these connectors. And then I realized, wait, why am I making my life harder on myself again? So what I did is I took some measurements of the 6-pin header from this adapter and some measurements from like one of these connectors that would plug into that header. And I designed a sort of a sleeve that can fit over this so that way I have it keyed so that I can only insert this in the proper direction. So this side goes facing this way towards where this LED is, and the key goes towards the left as we're in the view that we have. So this would just insert into that connector, and I made it so that it's like a really tight fit so that it can go all the way on there like so. And now I have a keyed connector that I can only insert in the proper direction. If I try to plug it in backwards, it's just not going to go. So that's tight enough that it's not going to just like slide off. So it's totally perfect for what I wanted. And the last thing that I wanted to mention is that the SD card adapter, which is used for like dumping ROMs and stuff, that fits on this 6-pin header. If you just plug that in, you can see how it's just sort of like wobbly and it's just like tilts like up and down. Well, I ain't about that life. So what I decided to do is I measured the height of the little signal relays, and knowing that the total height of a fully meshed set of pins and the female header is 11 millimeters, I designed and printed out this small block, which would have been, you know, like a total of 6 millimeters. I actually made it 5.8 millimeters tall. And this will actually just sort of like saddle over the two relays, like so. And then I can put in the SD card adapter. And now we can see that it's almost pretty much parallel. But the reason why I didn't make this exactly 6 millimeters tall to have a total of 11 millimeters height is that I'm going to put some double-sided tape like on the top and a little bit, if this would like stuff going out of focus, on the inside. So that way I can stick it onto the relays, because it's not like those ever need to get removed for any reason. I mean, unless they go bad, but then I can, just desolder them and pull the entire assembly off. And so the thickness of the tape should take up the rest of that 0.2 millimeters that I left off of the total like print height. So that way this should be like pretty firmly attached, and it shouldn't be like wiggling around, because even, with the block on there, like we can still kind of like tilt it back like that. But with the double-sided tape, it should be like totally firm in place, and it's not going to like go anywhere. Oh yeah, and one more thing. So these sockets, it's like a knockoff 3M socket. They like left a little tiny piece on there, so it actually looks like it says like BM, not 3M. But we can see how this, when we tilt the lever down, it closes down so that it latches in, whatever pins of whatever device you've plugged in there. Well, I didn't realize this until after I had already soldered this other socket onto this adapter. But this one's kind of messed up, and as we can see, the contacts do not open as much as they should. So this lever's like all kind of like limp feeling, and so it doesn't really fully open. So I'm going to take it apart and see if I can do something about it, because that's not going to work, or it's going to be obnoxious to try to get something in there properly. But luckily, these two screws are accessible from the top, so let's see what we can do about it real fast. And this adapter is used for testing like certain types of DRAM ICs. And so I'm not going to be using it like straight away, so if I can't fix this or whatever, I have extras. But it's going to require desoldering the entire thing, I think. So unless I can just like replace this top portion. So let's see what happens when we take this apart. It wants to like spring open. Okay, so what is the problem? Okay, so that looks right. So what the heck is it? Let's see. When we tilt the lever down, it's supposed to push on the... Okay, so it appears that this entire assembly is supposed to swing fully towards the front of where the little lever is, like that. And that would mean that these would have to be opened up a bit, like more this way. But for some reason, it's kind of being pulled back already. So that's why the lever's all just kind of wiggly. And it doesn't look like I'd be able to take this apart, because it looks like the soldered pins are holding this entire section in place. Like I can't pull this off. So unfortunately, it looks like I'm going to have to desolder the entire thing to be able to remove it and get one of my other ones. I wonder if it's the fact that they've been stored with this lever engaged the entire time. Well, no, that one's fine. You see, that one opens up all the way, and it's not all loose. So, of course, I had to pull off the one that was messed up and solder it in place. It's just my luck. Yep, the rest of these are fine. Oh, that is frustrating. Well, I'm not going to worry about that right now. I will deal with that at some other time. Future me can worry about it. All right, well, let's see if this thing will light up like a Christmas tree once we apply power to it. So, plugging in the LCD. And hopefully, all this stuff should come on as soon as I plug in the barrel connector. And if everything goes well, then I will try to update the firmware. So here we go. So I've got 12 volts coming in, and I've already verified that that power coming in through here actually goes through the 5-volt regulator first before it feeds this little 12-volt step-up, because this can only accept from like 4.5 to like 5.5 volts. So yeah, this should be fine. And let's see what happens. Here we go. 3, 2, 1. Yay! Oh, that white's kind of bright. Well, it looks bright on camera. It's not that bright in person. This is on, but I don't see anything. But let's see if it's the contrast control that needs adjustment. It does nothing. Other way. Oh, there we go. Oh, well, that's not good. Let's see. Is this actual reset or is it just for... No, I think that's just for... Well, shoot. Let's see. Let's take power back out, power back on. Did I put that in correctly? Yeah, that's on right. Nope. All right. Oh, this red LED, which is supposed to be VCC, is not on. So that should be 5 volts, I believe. All right. Well, it's troubleshooting time. Before I went too far with the troubleshooting, I decided to look up the Retro Chip Tester Professional Assembly Programming and Troubleshooting Manual, which is a thing. And because I've had this thing stored for, like I said, about 2.5 years, I completely forgot about the fact that the firmware does not come installed on the microcontroller. I didn't see anything confirming that for sure, but I believe that was the case, and I had completely forgotten like all the details about all this stuff. So we're going to try to load the firmware onto the microcontroller. Also, this red LED, I kind of traced the traces to see where it went. And I think it's actually controlled by the microcontroller, so we're probably not going to see this light up. I'm not going to like try to mess with this just yet if I don't need to remove it for any reason. I also pulled off the LCD and the voltage regulator board, and the SD card adapter has to be removed in order to be able to try to program this thing. Now, another quick little note that we're going to see on this manual is if we go to the programming the tester. Here we go. The experiences with the USB ASP are mixed. A recommendation for this programmer cannot be given. So it's, I guess, just my luck. Once again, it's not a recommended programmer. I'm going to see if I can make it work, and I'll try to go through the process. So as I mentioned, this is the USB ASP programmer. Now, when you plug this into your PC, the drivers don't automatically install for it. At least they didn't in my case, running Windows 10. Okay, I've got the device manager window pulled up, and I have actually unplugged the USB ASP from the USB port, but I'm going to plug it back in. And since I don't have the drivers for it installed, it should populate with under other devices. And there we go. So there it is, USB ASP. So we need to get a driver installed for it before we can actually do anything. And for that, I'm going to use this little utility called Zadig 2.4. So we're going to open that, and it's going to want me to authorize it. Okay, got to pull this over to this side. There we go. So we've got USB ASP. Right now, it's got no driver, and the driver we want is that libUSB Win32. So I'm going to hit install driver, and it's going to do its thing. And let's get this back up. It should, okay, there we go. So now it's under USB Win32 devices. Once this finishes, it's well, we can see it right there. So just got to wait for this to finish up. All right, and there we go. So the driver was installed successfully. Now we can go ahead and close this and close that. Okay, now, so as of recording this video, this is the latest firmware from Stefan. It says upload 1.0 Pro _ V 0.26. So when we extract that, we get this folder, which I'm actually going to just put on my C drive. So I'm just going to stick it in here, and that's just to prevent having to go through like a bunch of folders just to get to it. So everything we need should be inside. He also did include some batch files, but I'm going to try to do this manually just so we can get a good idea of what's going on. Okay, so I got a command prompt window, and I'm going to navigate to that folder. All right, so there we are, and you can actually add the AVRDude XC to the path. I do not have it added to this computer, but from here, the commands that we're going to run should work. So if you go back to the instructions, it says first, communication should be tested. This can be done via, and then we type in all this stuff into the command window. Okay, and I've got that entire string entered into the command prompt. So with the exception of this portion where it says C STK500, I have a C USB ASP because that's telling it which programmer we're using. And where it says PCOM5, because this is not on a COM port, I omitted that portion of the string. So everything else is exactly the same, but this is not going to work, as we're going to see. So when I hit enter, it gives us some information. It gets down to this portion, and it says right here that error program enable target does not answer. And so this didn't work. However, it tells us, well, first double check the connection, try again. I already know that the connection's fine, but it says use -B to set lower the bit clock frequency. So for example, -B 125 kilohertz. So I'm going to add that somewhere along the line here. I don't know if it actually makes a difference where we add it, but I'll just put it in this section right after the programmer name. So B 125 kilohertz, and it is case sensitive, so we got to make sure that the K is lowercase, the H is uppercase, and then the Z is lowercase. So when we hit enter again, this time it does read it. So it appears that it did work fine. It says right here, AVR device initiated or initialized and ready to accept instructions. So far it appears to be working. So I'm going to continue. And if we go back to the manual, let's scroll down to the next section. We need to program the fuses. So we need to run a similar set of instructions and switches, except that we're going to change where this was an R on all these fuses. Now it's a W, meaning that it's going to write this value. And I think the M stands for memory. I'm not sure. In either case, that's basically all we're changing to that string. And there we go. So I updated all of these. I'm just going to double check. So W0XF7 right there for M, and HFuse right 0XD7, and then :M, and 0XFF. Going to write that too. Okay, so that looks like it's correct. So I'm going to hit enter. Let's see if it works. And let's see. It looks like AVRDude done. Verified. It says writing 1 by eFuse. So it looks like it worked. Okay. So I think we're doing okay so far. And in this little section, it explains why we're setting the HFuse to D7. And then that way, if we update the firmware, the configuration is saved. So it doesn't delete it every time that we update the firmware if you've got, like a certain configuration going on. So let's continue. And this is where it says that we can do the update of the firmware using a batch file, but I'm not going to use the batch file. I'm going to type it in manually. Well, I mean, I already did the fuses manually anyway. All right, and we're going to jump down to the portion where we're actually going to program the firmware. So as we can see, the string here starts off the same way. We have the processor. We're going to keep that as USBASP. We're going to ignore that. But we're going to write -U flash and then write, and then it's going to, we're going to put in the name of the firmware. And in our case, we're going to replace this part with 2.6 because that's what I have. So a moment of truth. Let's see if this is going to work. I got to just get that string entered first. Okay, so let's hit enter on this and see if anything happens. Hey, the percentage is increasing, so that's good. There's no LEDs or anything to look at on the board, so everything's just being done within the window. And it's still going, so looking good so far. Hopefully we don't get an error somewhere in the middle of it. All right, and it's finally done. So it took about 2 minutes and 45 seconds. Is that 45? I think so. Well, just under 5 minutes. So it appears that it's done. So I think... Wait, never mind. It's still doing stuff. What is it doing? Verifying flash memory against trip. Okay, ooh, I'm glad I didn't unplug the thing. All right, so I guess now it's got to do this. And the reason why it's taking so long is probably because we're using such a low rate of data rate, or clock frequency. It's possible that maybe we can use a higher frequency, but I don't know what that would be just yet. And this seems to be working, so I'm just going to leave it alone until it tells me it's done. Okay, now that portion's done, and it took just a little less than the first one did. But it's not done yet. Ah, there we go. AVRDude done. Thank you. Oh, thank you. Okay, now let's see. So it appears that we've got the firmware flashed. Let's go and unplug the programmer. Let's plug in the DC-DC board. Let's plug in the LCD again. And that should be it. We should be able to apply power. I'm going to forgo putting the screws on those at the moment. I'll leave the SD card adapter out, and I got my power. Let's see if it does anything now. I didn't change the contrast because I shouldn't have to. Here we go. 3, 2, 1. There it is. Yes. And I am going to have to modify the resistor. I should have put on the one that I had originally calculated for that white LED, which was about like 330 ohms. So I am going to change that for sure. This LED is still not on. I don't know if that comes on when there's power applied to the socket. Not sure. Let's see. Without sticking something in there, can we have it try to test something? Let's see. Okay, so I think this is where we would select which type of chip we're using. And I can already see that this is going to be tedious, going through all the different numbers, although maybe there's a different way to do it. I don't know. I'll have to look up the manual. And this thing is giving us glare. Let's go ahead and pull it off. There we go. That's better. And let's fit a little more in that, or if this into the shot. So, I don't know. Let's see what happens if we just do so. Oh, there we go. So that lit up. Yeah, okay. So that lights up when there's power being applied to that socket, looks like. But then what about the active one? Oh, yeah, that also did sort of light up. It's dimmer than I was hoping, so I think I am going to have to change that resistor as well. And obviously, there's no chip in here, so there's nothing to test. But I can go pull out a few of the logic ICs, and then we can test it and see if the tests pass. If they pass with known good chips, then I can assume that everything is built correctly, and that should hopefully mean that there's no other issues. Okay, I've got 4 ICs that I grabbed that we can try testing this with. So I've got a 7404, a 120 or 165, a 4093, and a 4106. And according to the list of supported ICs, all 4 of these should be supported. So let's go ahead and try the 7404 first. And I'm just going to drop it in, lock it in place. Let's see. I'm going to hit OK on 7400 plus logic tests. I think I have to hit jump. Yeah, so let's go to 7404. There we go. So 6 or a hex inverter, and hit OK. Oh, that's cool. So yeah, that passed. Let's do it one more time. Yep, that seems to be working. Okay, let's go back. Looks like the only way to go back is to hit reset, but like I said, I haven't completely read the manual, so I'm not entirely sure. Let's try the 165. 7400. Yes. So this was what, a 165? Oh boy. Okay, many years later, we have arrived at 165. Okay, I'm hitting OK. And that chip passed. And like I said, all these should be good chips, so they're all passing so far. Let's do the 4093. Oh boy, here we go again. Oh, I guess you can just hold the button down. Ah, no, I passed it. Or was it not even on the list? I thought I saw it on the... Oh, wait, if we hit select, we can go back by 1. All right, so let's go ahead and click OK. And it passed. Well, I guess if we hit select, it also counts as a back button, so we can go back to the menu and select the new IC. So in this case, it's going to be 4106. And there we are. So hit OK. And that chip passed. All right, so I ended up going with an 820 ohm resistor for that white LED, and I'm now thinking that I might have even should have chosen like a 1K instead. It's still kind of noticeably bright, although it's not as obnoxiously bright anymore. And at least it lets me know at a glance, like I said, that, you know, I know that 12 is working, 5 is working, and -5 is working. And for the active LED, I ended up going with a 180 ohm resistor, and it's still not as bright as I would have wanted, but this is it's a pretty old LED. I'm sure I pulled this out of something like probably decades ago. but it still gives us a good idea, you know, that something's going on. So it's fine. I'm not going to complain too much about it. And with all of that, I think that's where we're going to leave this one. It appears to be working correctly. And like I said, I don't have anything specific that I need to test right now. But if I start messing with like some older stuff or whatever, you know, at least I have a tool that can help me with that. So I'm happy that it works. And I'm pretty disappointed that this thing was terrible. So I'm just going to replace this like behind the scenes. I'm not going to bother going through like desoldering it and putting a new one on. But that's going to do it for this one. So thank you all for watching, and I will see you guys around the bench. I wasn't planning on talking about this socket anymore, but after replacing the bad one with a new good one, turns out I ended up in the same situation. So I'm like, what the heck? What gives? Well, I discovered that there's actually a combination of things going on that caused, both of these now to go limp like this. And it has to do with the way these sort of like internal leaves are designed. So the way that these are made, at least as far as I'm guessing, is that they start off as a stamped piece of metal in about like this shape, and then they are bent in the middle. So you have two leaves that come together, and they're kind of shaped so that they kind of like sit apart like that. And then the skinnier piece in the middle is what becomes the pin that gets soldered onto, you know, whatever board you're putting this into. In the case of both of these sockets, when I went to solder them onto this board, what I did is that I engaged the lever fully, so that way all of the leaves are compressed, and then we'll pretend that this is the surface of the bench. So I set it down on the bench, just like so, and from above, then I started, you know, soldering in all the pins, making sure that, you know, solder like wicked up into the each one of the vias, and so that, you know, all the solder connections were secure and everything. And then when I released it is when I realized that they were all, you know, still kind of like compressed and they're just not opening all the way up. So if we take a look at a couple that I've got sitting under the microscope, we can see exactly what's happening. So because these are shaped in two pieces that are bent together, well, I mean, it's like one piece, but it's bent together to form the lead. Basically what happens is it leaves a gap in the middle. So both of these, you can see that there's like a little tiny gap, like right on the pin side. So what's happening is when I solder these in, solder wicks into the contacts, and because they are compressed, it makes it so that they stick together like at this point where they're supposed to be able to, you know, kind of like spread open. So in the case of this piece, I have already manually like separated it, and you can see how there's a little bit of a gap. And so you can see right inside where I'm pointing that that's where I broke the solder open. So this one works just fine, but this is how it started off as. So I have to like manually spread these open to get them back to their normal shape. And so if I would have started soldering these off when the leaves were already spread out, then solder wouldn't have been able to like wick as far in as it has. It may have only gone up to like right around there, and then, you know, it wouldn't like really continue like flowing up here. So if you take a look at the new socket that I installed, now it appears that all of these are basically being like compressed once more so that they don't open up as much as they should. But if I do this and I stick this set of tweezers in there and I kind of like pop it open, we can see that the first 6 are actually opening up as far as they should be. And I have not removed this or anything like to fix those, but those in the front do appear to be fixed, as the rest of them are not yet opening up all the way. So I figured out that there's an easy way to fix it without having to remove the entire socket and spread open all the pins. So what I did for those 6 is that I went from underneath, and you can see that I've added some flux there. So I heated them up, and as I'm holding this thing like wide open, the solder melts, and because these are, you know, kind of like little leaf springs, they spread open on their own, and then they go back to normal. So if I do that for all of them, I think I'll be able to get this socket back to normal without having to remove the entire thing all over again. So I'll try to do at least one on camera and see if I can, if we can like see it like manual or opening up on its own. So we'll try it on this 4th one down. Well, let's try it on the 4th and the 5th one down, just to see if we can see them both open at the same time. This is going to be kind of difficult because I have to kind of like hold it up like this and try to go in from underneath. I don't really have a whole lot of space here. So I'm just going to try to position myself in a way that I can see the bottom, but I can't. I'm going to try to hold this in place. This is kind of a pain, but let's see. Okay, so I'm going for the 4th one. Ow! I just touched my finger. It opened up a little bit, but I don't think I heated it up enough. It's kind of a really odd angle here to be at. Let's try it again. There we go. We saw it right there. It's kind of blurry, but we can see that this one opened up. So I'll do it on the 5th one as well. Let's see. Okay, I'm touching it right about now. There it goes. So it opened up. So if I just do the same to all of them, I should be able to get the socket to go back to normal, or at least mostly back to normal. Okay, and there we go. Looks like, yeah, that worked out pretty well. So all of them are open again. And let's see. This shouldn't really be a limp anymore. Nope, there it is. It's hard again. So we got some pretty good action there on the lever again. And I don't have to worry about trying to insert a part in there and having all those leaves like be a little too close together to get the pin in. So it's not as good as it was when it was brand new, but it's definitely useful now. So I'm just going to leave this like that. And I kind of learned a little lesson there is, yeah, don't solder these in with the lever completely engaged upside down, because solder is going to wick into the inside of them and make them all close up. And I mean, as I said, these are not exactly like high quality sockets or anything. These were like some of the cheapest ones I could find. So maybe like actual like 3M ones might be better, but I have no experience with them, so I can't say for sure. But yeah, there we go. Got that fixed, and all I have to do now is clean all the flux off because it's all nasty again. But yep, that's going to do it. So this is the true ending. Everything should be done, and actually, looks like I'm going to be updating the firmware again, because as of right now, there was a new version 0.27 firmware release, so I'll do that. But I mean, that's going to be the same procedure as I had already shown with the USBASP. So that's going to do it. Thank you all for watching. I will see you guys around the bench.